Packet forwarding. In this video, I am going to talk about again packet forwarding and also network device communication. You know that in previous videos, we have learned about the layer 2 forwarding in Ethernet networks. Now, I am going to talk about the layer 3 forwarding or routing. You know that when we are talking about the layer 3 forwarding means we are talking about the routing. Maybe you think that routing means sending traffic only from one network to other networks. It is okay, but here we have some explanation. We should know that we have two types of routing, or we have two types of the layer 3 forwarding. The first type of the layer 3 forwarding is the local network forwarding, means forwarding inside of our network. Here we should learn a little more. After that, we have other type of layer 3 forwarding. We call it packet routing. Let me to explain both of them. Here we have a simple scenario. In this simple scenario, we have a switch and also 4 computers connected to this switch. As you can see here, we have used one range of IP address 192.168.10/24, and the IP address of the computer 1 is 192.168.11. the IP address of computer 2 is 192.168.12, and then computer 3 13, and finally computer 4 14/24, as you can see here. Assume that we want to send the traffic from computer 1 with the IP address of 192.168.11 to the computer 4 with the IP address of 192.168.14. What is happening? Look at here. For example, we want to send ICMP echo to the computer 1, computer 4, 192.168.14. Actually, this is PC1, and you are typing ping 192.168.14. What is happening? You know about, and you know that here the first thing that should happen is the routing. Okay, in the routing step, first, computer 1 should compare its IP address with the destination IP address. Actually, because in PC1 we have 192.168.11/24 as its IP address, we should compare the first 24 bits of the destination IP with the first 24 bits of the source IP or the computer 1 IP address. The first 24 bits of the IP address of computer 1 is 192.168.11, okay? And also about the destination IP address, we have exactly the same first 24 bits, as you can see here. This is the first 24 bits of IP of PC1, and this is the first 24 bits of the destination IP. Because both of these two first 24 bits are same, this means that computer 1 and destination are residing in one network. Okay, actually we are talking about now local network forwarding or local network routing. As you saw here in the computer 1, we have seen routing, okay, but routing inside the computer, not routing with, for example, router. What is happening now? You know about it. Now computer 1, because is residing in the same network with computer 4, can send directly a traffic from itself to the computer 4. Assume that this is the ICMP echo request. Okay, we can send this packet directly from computer 1 to the computer 4 encapsulated in one Ethernet frame. Because of that, computer 1 needs to find the MAC address of computer 4. You know that in each computer we have ARP table or ARP cache, or address resolution protocol cache. Okay, first computer 1 should should search inside its local ARP cache or ARP table to find the MAC address corresponding to the 192.168.14. As you can see here, computer 1 doesn't have any MAC address. Actually, the ARP table of the computer 1 now is empty. Here we have one ARP table, include two important fields, IP and also MAC address. Actually, for each IP address that we want to send traffic to this IP address, we should find one MAC address. As you can see here, we don't have any MAC address. How we can find the MAC address? With the help of address resolution protocol or ARP. You have learned about the ARP in the CCNA class. Now let me to review the ARP process. Here you can see the ARP process. In ARP, or address resolution protocol, we have two important type of packet. The first packet is the ARP request, and ARP request is a broadcast packet, means destination MAC address of the ARP request is quad F, quad F, quad F. And also we have ARP reply. ARP reply is a unicast packet inside include the MAC address of the receiver. Look at here I want to review the ARP process. It is only review because you have learned about the ARP process in the CCNA class. Look at here, in this scenario, as you can see, computer 1 with the IP address of 192.168.1.1 and this MAC address is trying to find the MAC address of computer D. Okay, this is the computer D and this is computer A. Computer A sent the ARP request. As you can see, ARP request is a broadcast frame. Because of that, the switch should flood it to computer B, computer C, and computer D. Here you can see the contain the information that we have in the ARP request. Look at here. We have sender MAC address. This is the MAC address of the computer A. We have sender IP address, MAC IP address of the computer A, and also target MAC address quad F, and target IP address 192.168.1.4. Okay, if you want to draw the real ARP packet, you can use this, for example, information. This is the ARP request. Okay, include the this information. This is our ARP request, but you know that we should encapsulate ARP request with the Ethernet header and trailer. This is the FCS or Ethernet trailer. This is the Ethernet header. Here we have preamble, and after that we have SFD or startup frame delimiter. Destination MAC is the quad F, again dot quad F, then quad F. Okay, and after that the source MAC is the MAC of PC1. Let me to use MAC 1 or MAC A. MAC A means MAC of the PC A. This is the Ethernet header, and also here we have a type, and in type you know that we are using the code of ARP 0x806. It is not important for us now. This is our Ethernet frame, and actually this Ethernet frame, as you can see, is a broadcast frame. We are sending this broadcast frame. All systems that are receiving this broadcast should accept it because the destination MAC address is broadcast. But when they verify the ARP request, in the ARP request we have, if you have if your IP address is 192.168.1.4, please answer to me with ARP reply and include your MAC address. Okay, only the PCD has this IP address, and because of that, the PCB and PCC, both of them should drop the ARP request. Only the PCD should answer with the ARP reply. Here you can see that ARP reply is unicast because here inside the ARP request we have the source MAC address or sender MAC address. The computer D can answer directly to the computer A. As you can see, we have ARP reply. The ARP reply contains the IP. The sender MAC is the MAC address of computer D, and target MAC is the MAC address of computer A. This is unicast. And when computer D is sending this ARP reply to the computer A, finally in computer A, in the ARP cache or ARP table of computer A, we will have the MAC address of computer D. Here you can see, for example, now we have 192.168.1.2 means the MAC address of computer B, and also computer C, we don't have MAC address of computer D. After receiving this ARP reply inside the, for example, ARP cache, we will have this IP address 192.168.1.4 with the MAC address of the computer D. Actually, because at the first we didn't have the MAC address of computer D, we have used the ARP, but after receiving the ARP reply, now we have this information in the ARP cache, and for the subsequent packets, okay, we don't need to use again the ARP process. Here we will have the MAC address of the computer D. This is 00, then 1, for example, E0C. And after that, for example, here you can see the MAC address 0C and then E7. After that, AE and then E1. That's it. Okay. Because of that, now we know about the ARP process. Actually, when C1 understand after the local network forwarding that C4 is residing in its network, okay, here let me to show you again, it should send the ARP request. Okay, ARP request is a broadcast, and because of that, this ARP request should flood it to all other systems inside this network. Okay,